This is the last of 4-6. These are the fun but challenging problems. These are the kinds of things that you're going to run into if you're going to be taking trigonometry or you're going to be taking calculus. And these are primarily problems that involve substitution of different forms. And the key, just like with the 3 to the x, is if I look at the center term, this is a quadratic equation. I've got circled to the 1, and here's the same thing, which is squared. That's an equation in quadratic form, so that we know that the blob is equal to the log of x, which is the center term. And then if I square both sides, I get the log of x squared. So this becomes b squared minus 2b minus 3 equals 0. Now it's a quadratic equation for which you've got the means to solve it. It's either going to be solved by using a quadratic formula or factoring. So this is b and 3 and 1 and minus and plus, so that b is minus 1, b is plus 3, but I'm not interested in b, I'm interested in x. So b is the log of x, so you bring it back. So log of x is equal to negative 1, and the log of x is equal to 3. Now you have some logarithmic equations. What base is this logarithm? 10. This is the one that's on your calculator. So now I just rewrite 10 to the negative 1 is equal to x. So x is 10 to the negative 1, which is 1/10. And x to the 3, or 10 to the 3 is equal to x. X is 10 cubed, which is 1,000. And both of those work. If I look at the domain of this guy, it's the log of x is the function, and x has to be positive. And in both cases it was, so it's not going to be a problem. Now this one's trickier, and it is trickier because it's not quite clear what it is. If I can't divide through by the log of x, that's not going to work, because at which point it's a function, can't happen, and that's a log of x squared. And these two things are different. Here x is squared, and here it's the whole thing that's squared. But something that I do know is I can bring the 2 down in front. This is 2 natural log of x is equal to the natural log of x squared. So you're going to bring everything to the same side, 0 on the other. So 0 is the natural log of x squared minus 2 natural log of x. Now once you get used to these problems, you don't have to make a substitution. I can factor out a natural log x, but we're going to make a substitution because here is a blob and here is a blob squared. So it fits the substitution pattern. So b is equal to the natural log of x, and if I square both sides, b squared is the natural log of x, the quantity squared. So 0 equals b squared minus 2b. That factors. This is b times b minus 2. So that b is 0, b is 2. Well, we don't want b, we want x. So what this says that if b equals 0 and b equals 2, b is the natural log of x equals 0. Natural log of x equals 2. What is the base on natural log? E. This is the same as log base e of x. That's 0. Log base e of x is 2. And now you'll do what you did on the other one, is you just rewrite it. E to the 0 equals x, or x is 1. And e to the 2 equals x. Or x equals e squared. That's an exact answer. And again, what you could do if you wanted to, you could, that's 2.71 squared, or just do it with your calculator, do e squared and round. Either way, doesn't matter. Substitution. It is not something that comes naturally. It comes naturally after you've worked tons and tons of different varieties of problems. And I had to learn actually more so how to use it in the engineering calculus. Business calculus, we do a lot of substitution in 212, but we do substitution to do other things. Usually not to solve equations. But substitution is an extremely powerful tool. This guy, there are a couple of things that you can do. One of the things is, if that wasn't there, I could work the problem. If that were just an x, I'd just say 3 to the 0 equals x. But I can still say that. I can say 3 to the 0 is equal to the argument, or log base 4 of x equals 3 to the 0. Log base 4 of x equals 1, and then I get to do it again. 4 to the 1 equals x, or x equals 4 to the 1. 4 to the 1 is just 4. This is a problem where, its bark is, is worse than its bite. It looks worse than what it really is. It's more scary because of the complication, but it really isn't as bad. When I look at this, I just said, okay, if that wasn't there, could I do the problem? The answer is yes. I mean, it's a regular problem. Well, then why can't I just do that? Take 3 to the 0 and have it equal that argument. That kind of takes it out of the mix. Or you could, if you wanted to, let b be equal to log base 4 of x. Then you would say log base 3 of b equals 0, and then you'd work it out. And then from here, you would say b equals 3 to the 0, which is 1. b equals this guy, and then you'd work it down. At that point, then b would be log base 4 of x equals 1, or 4 to the 1 equals x. X equals 4. That'd be another way of coming at it if you wanted to do a substitution. Either way.